Hello, welcome student. Welcome to our today's session that is related to class 9th, chapter 10. Today we will discuss new theorem and we will discuss our new exercise which is related to this theorem. So our theorem is measure of angle subtended to any point on the circumference of a circle from the same arc is equal to the half of angle subtended at the center by the same arc. Means if this AB arc is there and it is subtending the angle AOB at the center and APB at any circumference of the circle, then this AOB, it is twice of APB. This we need to prove. Okay. So first of all we will do the construction. We will join P to O till D. Now we are having a triangle, this triangle AOP. Now see, in this triangle AOP, we are having OP and OA. Both are equal because radii of the same circle. So the angle, opposite angle, this one, angle APO and angle OAP, both are equal because the angle opposite to the equal side are equal. And one more thing we are having the exterior angle property, that this angle AOD, it is equals to the sum of opposite two angles. Okay, and just see, if these two angles are equal, we are taking only one, this one. Means we are taking this AOD, it is equals to twice of APO. Okay, this we have done here. Now same thing we will repeat with triangle BOP. In this triangle also OP, it is equals to OB. Okay, similarly the opposite angle, this one OPB, it is equals to OBP. Same we will take exterior angle property BOD. This angle is equals to the twice of this one. Now see, we are having the two equations, that angle AOD, it is equals to twice of angle OPA and angle BOD, it is twice of OPB. Just see the diagram here. This one is twice of that one and this one is twice of this one. Now what we will do, we will add those. Once we have added those two angles, so the sum of these two angles means angle AOB, it is equals to twice of APB. So this thing we have proved and we will utilize this in our questions also. One more thing is there, one more theorem is there, which is that theorem that same arc subtend equal angles on the circle. Means if one more angles we make here with the same arc, then the measurement of both the angles is same. Okay, means if I take one more point, that point N, and I join this AN and B, thus angle APB is equals to ANB. Okay, this also we will utilize in our questions. One more theorem is there, the opposite angles in a cyclic quadrilateral are supplementary. Now the term is here cyclic quadrilateral. So what does cyclic quadrilateral means? Means all 4 points of a quadrilateral is on the circle. Just see A, B, C, D, all 4 points on the circle. So opposite angles in a cyclic quadrilateral are supplementary, means opposite side. If D then B, A then C. So here we have to prove that this one, we have assumed it as alpha or beta, you can assume it as x or y. So sum of alpha and beta, it is equals to 180. This we need to prove. Okay, now what we have assumed that this ABC, it is an arc. If this one is an arc, then the angle AOC, this one, it is twice of alpha. Okay, from the previous theorem. Again, this one angle AOC, it is twice of beta. And one more thing we have, that sum of these two, it is 360. Means twice of alpha plus twice of beta is 360. Then 2 will be common and alpha plus beta is 180. So if one angle is known to us, we can find out the another one. If alpha is known to us, we can find out beta. If beta is known to us, we can find out alpha. Okay. Now exercise 10.5. First question, just see this diagram given to us. In this angle BOC, it is 30, angle AOB, it is 60, D is upon ADC. So what do we know? That AOC is twice of ADC. Okay, means ADC is half of AOC and AOC is 60 plus 30, that is 90. So we are get 45 degrees. That is our answer. Simple question. Now see our second question. This is a diagram. A chord of a circle is equal to the radius of a circle. Okay, this AB, it is equal to the radius. You can say AO, you can say OB. Now find the angle subtended by the chord at any point on the minor arc and also on the major arc. You have to find out ACB and ADC. Okay, now see, AB is equals to OA is equals to OB, means this is an equilateral triangle. All angles are 60 degree, means this AOB, this is also 60. Okay, now if this AOB is 60, then what this one, what the remaining, we can find out easily. Okay, and now see, if this AOB, we can find out the reflex of AOB also. That one is 300. Okay, now the same, we will use the method, previous theorem. If this one is 300, this one is half of this one, 150. And if this one is 150, you can find out the opposite angle. 180 minus 150, that is 30 degree. Okay, you can use any method which is you find the easier one for you. Okay, so how we have solved it? This one is 60, then the reflex is 300, this D is half of it, and this opposite one is 180 minus 150, that is 30. Okay, easier one. All the questions are easier if you know the theorem then only. Okay, now see question number 3. This is the diagram given to you. PQR is 100 and PQR, their point on the circle with center O. We have to find out OPR. What we have to find out? OPR. Now see the diagram here. This POR, okay, just see the reflex of it. Okay, this one is an arc. The angle subtended on the center is reflex of POR, and here it is 100. So if this one is 100, then the reflex is, how can you find out? Twice, means 200. Okay, then the inner one will be 160, inner one will be 160. Now see, this OP and OR both are the radius, means both are same. If this one is 160 and the rest you assume as X and X, because both are same. These two are the radii, both are same. So X plus 160. Okay, then that is equals to 180, because sum of all angle is 180. Then what you can find out? It is 20. And if sum of both is 20 and both are same, then the value of single one, what will be the value of single one? It will be 10 degree, because you will you will divide it by 10. What you will do? You will divide it by 10. Okay, now next, question number 4. Just see question number 4 here. In question number 4, just see the diagram. It is diagram given to you. Now, what you have to find it out? Two angles are given to you. We have to find out BDC. Okay, now see. Now see this angle, triangle ABC. In ABC, 69, 31. We can find out A. Okay, sum of all angle is 180. We can find out A easily. And once we have find out A, then this BAC and BDC both are same. Because what is the reason? Angles in the same segment are equal. Okay, angles in the same segment are equal. So we can find it out easily. Now question number 5 is here. In question number 5, 4 points are given to you. Okay, AC and BD intersect at E. BEC 130, this one is 20, we have to find out BAC, this one we have to find out. Now see, this BAC, we have to find it out, this one 110. Now what we have done here, just have a look. This BEC, this one is the exterior angle, and this exterior angle of a triangle, it is equals to opposite two angle, 20 and this D. Okay, BDC and 20. Just see, just leave this portion. This one is a triangle EDC. In this 130 is the exterior angle, and it is equals to the sum of EDC and ECT. So 130 is equals to EDC plus 20. Then EDC is 110. Now have a look to the diagram. BAC and BDC both are same, angles on the same segment, so both are equal. If this one is 110, the remaining one is also 110. Okay, now question number 6. What question number 6 is? This one is the cyclic quadrilateral. In diagonal intersect at E. This one is 30 given to you. We have to find out BCD, and what is given to us, that AB, it is equals to BC, and we have to find out ECD also. Okay, just see the question looking little bit typical. Now let's just see here, BAC, and another one is BDC. If you see this, BC is an arc. This arc subtend equal angle. If this BAC it is 30, then BDC will also be 30. Now in this triangle, this we are having 70, this one we are having 30. We can find out this C. This one will be 30 plus 70, 100, 180 minus 100. This one will be 80. Okay, this one we have find it out 80. Now, this triangle we are having, these two angles are equal. Sorry, these two sides are equal, AB and BC. If these two sides are equal, then angles are also equal. This one is 30, then remaining is also 30. And once we have find out the remaining, the whole is 80, then this one remaining is 80 minus 30, that is 50. So B, C, and you can say D. Okay, this one is 50 degree, which we have to find it out. Sorry, ECD. Okay, this one is ECD. Because ECD is the sum of EC. So, we have to find out BCD. BCD is the sum of ECD and BEC. Once we have find out BEC, then subtracting from the whole, we can find out EDC. Okay, and regarding BCD, that we have find out, that is 80 degree. So this one, all the question theorem as well as question number 1 to 6. In the next video we will discuss the meaning of the question. Till then, thank you. Take care.